As we start talking and working about determining the subnet number of an IP address that you're given, you're going to be amazed at two things. First off, you're going to be immediately amazed at how simple this operation is. Secondly, over time, as your studies get more complex, your troubleshooting scenarios get more complex, and your career progresses, you're going to be amazed at how handy this little skill is. Because it's really easy sometimes when you've got different masks in your network, you're looking at an address and you think, well, okay, here's A, here's B, and they're both on the same subnet. Or you're looking at a host that can't communicate with other people and saying, well, what subnet is this on exactly? What's going on here? And it is amazing how often that comes up where communication is just a communication problem comes up because someone thought a host was on subnet A and it was actually on subnet B. So for example, let's look at one example of this, and then we're going to work through 5 of them on the board, so make sure you have something to work with. On what subnet is the IP address 10.17.214.255.255.192.0 found? It's one of those long-winded masks, those dotted decimal masks. Well, all you've got to do to solve this is break the IP address down into binary, add up the network and subnet bits only, and you're done. That's it. And let me show you exactly what I mean. Like I said, then we'll go through some examples. That address in binary, we've got the 10 for the first octet. That's going to be 4 zeros and then 1010 because we have the 8 and 2 bits set. For 17, when we convert that at 0001, 0001 because we have the 16 and the 1 bit set. Then finally, for the 2, it's all zeros all the way down to the 2-bit, which is set to 1, and then another 0. And then for 14, 0000, and then your 8, 4, and 2 bits are set to 1, and then finally your 1 bit is set to 0. So there's our address in binary. The subnet mask converts to 18 in prefix notation because we know that the first octet is all ones, 255, so that's 8 right there. The second octet, 255, all 1, so that's 16. And then when you look at 192, as you're probably already doing without looking at having to write it out, that has the 128 and the 64 bits set. So you got 2 more bits right there. So as you go across, it's 8 plus 8 plus 2 gives you /18. You add up the first 18 bits of that value that you just converted, and then convert it back to binary, and you're done. And the subnet upon which that address is found is 10.17.0.0.255.255.192.0. When you're answering a question like that, don't forget to include the mask. Okay? So that's it. That's all you do. So you see now that your binary conversion skills and you're going, binary to decimal, decimal to binary, we're going to use them both here. So I'm going to go ahead and bring up our previous little board. And we're going to start with 217.17.23.200/27. What subnet is this on? And I'm going to show you one other way to save time with this. You just have to be careful with it. I'm giving you a dangerous tool here. With great responsibility comes great responsibility. I know it doesn't go like that. So let's start converting this 217. Can we subtract 128 from 217? Sure we can. And if we subtract 64 from that, what have we got at that point? I want you to start thinking about number units 2's here. So we've got 2 numbers here, 192. So it's 217 minus 192. So we have 25 left. We don't have any 32s in 25. We do have a 16 in 25. Leaves us a remainder of 9. 9 minus 8 is going to leave us a remainder of 1. And it doesn't hurt to go back, especially when you're practicing, just make sure you got that right. So if we're going across and adding up everything with the 1s, we've got 128 plus 64, that's 192, plus 16 is 208, plus 8 is 216, plus 1 is 217. Now we're going to convert 17 over, and we can't subtract 128 or 64 or 32 from 17, so we're still working with 17. We can subtract 16 from 17, which leaves us obviously a remainder of 1. So we can put zeros here and then a 1 there. So we have our 16 and 1 bit set for 17, and you're done. Now we're converting 23. So we know we can't subtract 128 or 64 or 32 from that, but we can subtract 16, and that leaves a remainder of 7. We cannot subtract 8 from 7, but we can subtract 4, 2, 1. So we add those up, 16 plus 7, 23. 200. We know we can subtract 128 from 200. That leaves us a remainder of 72. We can subtract 64 from 72. That leaves us a remainder of 8. And here's the deal. Once you reach this number of bits that you've converted, you can actually stop there. If you don't want to go ahead and finish this conversion, you don't even have to, because you have the 27 bits you need to finish it up. Now you might say that doesn't really save a lot of time. In this example it doesn't, but if this was a /10, why break the entire address down if you don't have to? So it's just, that's a little more advanced. If you want to leave that behind, you could. But right now, if you add up everything we've got right here, it would give you the subnet, which would be 217, 17, 23, 192/27. That's your answer right there. But if you want to go ahead and finish it out, you just put a 0 here. Then we subtract 8 from that. 128 plus 64 plus 8, that's 200. So you put zeros for everything else. So at that point, all you do is add up the first 27 bits. Don't add up everything, because if you add up everything, of course, we would get this. So if you do that, /27, you add up everything in the first, second, and third octets, and then you add up the first 5 in the fourth one. That right there, first 3, that would be 27. So your subnet then is 217, 17, 23, 192. That /27. That is the subnet that contains the IP address we were given. Pretty cool. And like I said, it looks like a complicated operation. How in the world am I going to figure this out? But you can see it all goes back to the fundamentals, every single bit of it. So I'm going to stop this video, and in the next one we're going to do 4 more exercises on this, and I will see you on the next vid.